All right, so this is the third and final video for our class for March 1st. In this video, I'm going to show you how to use Excel to calculate those capital budgeting tools that we looked over in our first video. In your textbook, under the Investment Detective, for this section for capital budgeting, it's 2 pages long, and the table that is in Excel, and this is also out on D2L for you, is on that second page. And I'm going to show you how to calculate NPV, IRR, MIRR, profitability index, and the payback period for each of these projects. And then we're going to do an NPV profile for projects 7 and project 8. So you can see what that looks like in Excel, and honestly, they do a better job. I can do a better job of graphing in Excel than I can with paper and pencil. So to calculate NPV, let me show you the cash flows first. So for project 1, so here's our project numbers. We have 1 through 8. They all have the same initial investment. And if we say this is in thousands of dollars, then our initial investment is $2 million. In thousands of dollars. So our first project, we would invest $2 million at time 0. So that would be today. And then for each year, we would have a positive cash flow of $330,000, and then in year 8 we would have $1 million that we would receive in cash flows, in cash flows. And from that we can calculate the NPV, and I put 2 amounts in here at 10% and at 18%, so you could see whether or not the project would be acceptable at 10% and whether or not it would be acceptable at 18%, and those are the weighted average cost of capital. So 10% weighted average cost of capital. The IRR, the MIRR, I showed you the calculation for that. If we do it longhand, it is kind of time consuming. Excel's wonderful. We don't have to do it that way in Excel. The profitability index, again, I'm going to show you how to demonstrate how to do this in Excel. The payback period, and then at the end for these last 2 projects, we're going to do a NPV profile. So let's get started. Using NPV in Excel, there's one thing that you need to remember, is that in the NPV function in Excel, the first dollar amount, Excel assumes that occurs at the end of year 1, not the end of year 0. So it's going to discount that first cash flow back by 1 year. So we don't want to put the time 0 cash flow in the NPV function itself. So I'm going to start off here by putting equals, and then I'm going to highlight the time 0 cash flow, that initial investment of $2 million. Then I'm going to put a plus sign in, and I'm doing that, you can see right up here, plus NPV. The rate is the weighted average cost of capital. In our first example here, we're going to use a 10% weighted average cost of capital, so I'm going to put in 0.10. This is different than in your calculator. In your calculator, you put a whole number in. In Excel, you put in the decimal. And then comma. And then the rest of these are the values starting with the first year. I'm going to highlight all these. Oops. Do that over again. So I have all the years here, even the ones after that, and you'll see why when I get to that, when I get to the end of this, and then I put a close parentheses, and I get my answer. My answer is $73,090, because these are in thousands of dollars. So I can make my life a lot easier and not have to calculate this 8 different times by just going down here and seeing the square there. When I put my cursor on it, it makes a plus mark. I hold down the left button and scroll over, and it fills in all of my NPVs. And you can see what those are. So we have 73.09, negative 85.45 at 10% weighted average cost of capital, 393.92, 228.22, 129.70. This is a nice little check. If we discounted 2,200 back at 10%, it would be equal to $2,000 the year before. So our NPV is equal to 0. 165.04 for project number 7. And then finally 182.98 for project number 8. For the second one, we have an NPV at 18%. So I'm going to do the same thing. I'm just changing the discount rate. So I put in equals my 2,000 plus NPV, open parentheses, the rate is 0.18, comma, highlight cash flows for years 1 through 15. Again, don't include year 0 in that one because we included it before. I get negative 476.16, and that makes sense. It should be lower because we're discounting it at a higher rate. My IRR, for IRR, Excel is really nice, equals IRR, equals IRR. So there's two arguments here, values and guess. So the values are just highlighting the cash flows, and we include the year 0 cash flow here. If we don't, we get an error message. So we include the year 0 cash flow, we highlight all the cash flows, it will tell us our return. However, if we have a negative cash flow, so for example, for year 4, for project 4, we have a negative cash flow out here, so it may cause a problem for us. But we have IRRs, and so we can have, as I showed you in the notes, the part 1 notes, we can have multiple IRRs. So if we think there's going to be multiple IRRs, we'll put in a guess for what we think the IRR will be. And so if there's multiple IRRs, then the Excel will choose the one that's closest to our guess. I'm not going to include a guess here. I'm just going to put in all the cash flows, close the parentheses, and get the IRR at 10.87 in that case. So I'm going to go ahead and grab these two. So I'm going to grab that one, take it all the way over. Not surprisingly, everything goes negative because we're using a higher discount rate than the 10% discount rate. The IRR, oh, that shouldn't have happened that way. We'll fix it. Fix that here in a minute. There we go. So 10.87, 6.31, 11.33. Kind of our weird one gives us an IRR of 12.33, which looks okay. It's not really strange. We'll double check that with the MIRR, because MIRR will not have the problem of multiple IRRs because we set the reinvestment rate there. So for MIRR, we put in equals MIRR, open parentheses, the values. So just like we did before, we highlight like we did with IRR. We put a comma, and then there's 2 more arguments after that. If I look down here, we have the finance rate. So that's our weighted average cost of capital. That is the cost of, the cost of equity and the cost of debt for the investments that we make as a firm. So it's 10%, 0.10. The next is the reinvestment rate, and that's what I was talking about whenever I calculated MIRR and talked about the difference between NPV and IRR being the assumption of what the reinvestment rate was. So if you remember for IRR, the assumption for the reinvestment rate was the IRR that we calculated. So for project 1 here, if we used IRR, we assume that we're reinvesting this $330,000 per year back at 10.87%. If we're using NPV, so for this NPV at 10%, we're assuming we're reinvesting back at 10% instead of 10.87. You can choose whatever reinvestment rate that you want. For our purposes, we're just going to use the weighted average cost of capital. I press enter, and I get 10.49%. So I'm going to grab that and pull it over, and I get 10.49%, 8.41, 11.33, 10.65, 10.46, and so on. And the one that I was kind of questioning was this one here, where we had a possibility of having multiple IRRs, We have 12.33 for the IRR, 10.65 for the MIRR. And what you'll see is that the MIRR should be between the IRR and the weighted average cost of capital that we're using. So we're using a 10% weighted average cost of capital, and so the MIRR is less than the IRR. This is kind of an interesting case because we get the same MIRR and IRR, and that's really a function of the fact that we only have one cash flow and it's 15 years out. So for the second example, we have equals MIRR. Again, we're going to highlight the same values. Comma. Now our weighted average cost of capital is 18%. So I put in comma 18%. You can see I'm doing that up here. .18 for our reinvestment rate. Close parentheses. And so you'll see that our MIRRs in this case will be a little bit higher because we're assuming a higher reinvestment rate. And that's what we get. Now, again, our MIRR is the same because of the situation with our cash flows. Our MIRRs are the same here because we only have one cash flow and it's 1 year out. Profitability index. I'm going to use the kind of the official way of calculating this. I'm going to take the present value of the future cash flows discounted back at the weighted average cost of capital divided by the initial investment. So here I'm going to put in equals NPV, and the rate is 10%. And you'll notice that I'm not including my time zero cash flow. I'm just taking all those cash flows from time 1, and let me do that again, time 1 through time 15. Then I'm going to divide that by the initial investment. I'm going to take the negative of the initial investment, so it makes it a positive number. Okay. And then I want to change this from a percentage just to a regular decimal. So our profitability index is 1.04 for the first project, 0.96 for the second project, which is what we would expect because our NPV is negative at 10%. So our profitability index at 10%, our weighted average cost of capital at 10%, and we go across here and we can see that they're all above 1 except for this first one here where we had an NPV equal to 0. I'm sorry, this is number 6. But and then this one here where our NPV was negative, but the rest of them are above 1. I'm going to do the same thing here at 18%. Again, equals NPV. My rate is 18%. I'm going to highlight all my cash flows. I'm going to divide that by my initial investment. Again, I'm going to make that a negative number. And not a surprise that these are all less than 1 because all of our NPVs were less than 1 at 18%. The payback period, not an Excel function that I'm aware of for this, so we kind of have to calculate this one out by hand. Some of these are going to actually be pretty easy. So for the first one, we can just, because 7 times 330 is more than 2,000, we can actually just divide 2,000 by 330 to get the number of years. I'm going to make that negative. Negative 2,000 divided by 330. And it pays back in 6.06 years. So prior to this 8th year, it pays back. So it's just 330 per year. In our second case, our payback period is equal to the 2,000. I'll just put 2,000 plus the 16,666 plus the 334 gives us 0 left. So our payback period in this case is 2 years exactly. Oops. In the third case, our payback period is 15 years because it takes that long to get the money. Or, yeah, 15 years. In the next case, this is where we would just need to add things up until we got to 2000. So I have, I'll do it over here, equals the negative 2000, put that there, equals this plus the 160. So then what I can do is actually just drag this down, and each year represents another year in the project until that number gets to be negative. And so we see here in the 6th year, we've almost got it paid off. We only have $23,000 left to pay off, so I'm going to take this $23,000 in the 6th year, I'm going to divide it by the 442 in the next year, and I get 0.05. So I'm going to put our years here. We have year 1, year 2, year 3, year 4, year 5, year 6, and then we have 0.05 years. And remember, I got this by dividing the remaining amount, the 23,000, by the amount the next year in year 7, 442,000. So we have 6.05 years as our payback period for this one. The next year we have 2,000, and then we have an annuity of $280,000 or $2 million, and then we have an annuity of $280,000 for 15 years. So again, we can just take that 2,000, our initial investment, and divide that by $280 per year. We get a payback period of 7.14 years. Here we get a payback period of a little less than 1 year. So I'm going to just take 2,000. Actually, yeah, I'm going to take 2,000 divided by 2,200. We get a payback period of 0.91 years. So that's a pretty quick payback. In this case, our payback period, we would add back, we would have 2,000. In year 1, we would add back $1,200. And then we only have $800 left to pay back, and we have $900 in cash flows in the next year. So I'm going to take 800 divided by $900, and I get 0.888. So our payback period is really 1.89 years for project 7. And then finally for project 8, we have a weird situation where we have a negative cash flow at time 1, a negative cash flow at time 2. And so that's actually going to decrease the amount of, our cash inflows. So I'm going to start here, put an equals negative 2,000, our initial investment. Oops. At year 1, we actually go more in the hole. So we're getting further away from paying it back. Year 2, or even further in the hole. It's year 3. There's year 4. There's year 5. There's year 6. So at the end of year 6, we have $100 left to pay off. Going to divide that by the 2250. So it gives us 0.04 years. So our payback period here is 6.04 years. So again, year 1, year 2, year 3, year 4, year 5, year 1, year 2, year 3, year 4, year 5, year 6, and then 0.04 years for the last year. So it's 6.04 years. Okay, so now you can see, and again, I didn't really put, this is just 15. You can see our 8 different projects that the company can consider and get an idea of what one you would say is the best one. So if I'm looking at this, looking at the MIRR, if I say it's at 10%, so first of all, we wouldn't accept any of these projects if the weighted average cost of capital is 18%. Okay? None of these are acceptable projects. None of them meet the threshold. They don't earn back 18%. So the last thing I want to do is do an NPV profile of these last 2 projects. And so with an NPV profile, we have the weighted average cost of capital, and then we have our projects. So this is project 7, and then project 8. And I'm going to take this weighted average cost of capital from 0% to 20%, just to show you what that looks like. So I put 0%, 1%, 2%, 3%. Then I go down here, get the nice little plus sign. I'm going to scroll that down. You can kind of see in very light numbers how far I go down. So I'm going to take that down to 20%. So here I'm going to put in equals the initial investment for project 7 plus NPV. Now my rate will be the amount in the first column of my table here, then comma. I'm going to highlight the cash flows after times 0. And what I want to do here, because I'm going to drag this down, I want to go to I4. I'm going to press F4 on my computer. And what that does, it puts a $sign before the I and before the number 4, and it locks that cell in place. And I'll show you when I drag this down, it will actually lock that cell in place. I don't want to lock in place the discount rate or the weighted average cost of capital. I want that to change as I pull this down. I'm going to put my cursor here on I5. I'm going to do the same thing. I'm going to press F4. It locks it in place. And then I'm going to put in F4 here again, so it locks my range of cash flows in place. I press enter. So project 7's NPV at a weighted average cost of capital of 10% is $560. I'm going to pull that down, and you can see what happens here. As we increase the weighted average cost of capital, our NPV decreases and becomes negative. So here it should say project 8. So for project 8, I'm going to do the same thing. I'm going to put in equals. I'm going to highlight the initial cash outflow and then again press F4 plus NPV. My discount rate, I'm going to highlight that first column again, comma, and then I'm going to highlight the cash flows for the project, and I want to lock those in place again, so I press F4, F4, close parentheses, and then I pull those down. So now we have our NPVs for all of the weighted average cost of capital between 0 and 20% for the 2 projects. I'm going to highlight that table, I'm going to go to Insert, and I want to insert a chart. I'm going to choose a scatter chart here, and that's a decent one to use. So we can see our project 7 or project 8. I can call this NPV profiles. And we can see here we have a crossover rate right about at 10%. So at a weighted average cost of capital of less than 10%, we'd prefer project 8 because it gives us a higher NPV. Okay. At greater than 10%, we prefer project 7 because it gives us a higher NPV. And that's it. Hopefully that's going to be what you need for the case for this next week. If you have any questions about the case, please don't hesitate to email me, contact me. Hopefully I will be back in my office on Thursday. That is my goal. We will not meet for class next week. However, your case will still be due, and I'm going to give you a team project assignment to work on. So unfortunately, I'm unexpectedly not in class this Wednesday, March 1st, because my son is having some health issues where he's been admitted to the hospital up in Kansas City. But I'm checking my email pretty frequently, so please let me know if you have any questions, any projects, any problems with the videos. I kind of recorded them kind of late in the evening, so I apologize if I'm not sounding the best. So let me know if you have any questions or issues or problems with the videos or understanding any of the topics. Next week I'm going to be at a conference in Little Rock, and I plan for this well in advance. I'm going to put together something this week where you will still work with a group, and maybe that'll be electronically. You can certainly always meet in person and go over it. Now I'm going to have you work together to kind of verify your decisions and see if you might change your mind when working with a group, and then you'll turn that into me as well. Oh, please let me know if you have any questions about anything, and please don't hesitate to contact me if there's anything I can do for you. Thanks. I'll see you in 2 weeks, if not sooner, and I will put out information about your midterm exam in the next few days. All right. Have a good week.